Thank you very much, Carolina. And I will bring now to you 3 slides which deal with the mass balance systems that are discussed on European level today. They're all looking at mass balance systems in a similar way, but not identical. So with that, I hope to provide some clarity of what the systems are and why we are using mass balance or propose to use mass balance systems for the chemical recycling and then going through the chemical and plastic infrastructure that is already today in place today. What you see here on the first slide is actually an aerial shot of one of our sites in the Netherlands, Terneuzen, where we produce a lot of polyethylene. We are producing there as well various other chemicals and products for the overall industry in Europe. That goes into other applications like mattresses and various different products. So we have multiple inputs and we have multiple outputs. What's that, for example, mean on the right-hand side? And you see there various boats next to the site on the port. We bring in for, let's say, one of the crackers, 1.5 million tons of naphtha in that we then crack and make into multiple individual product lines. And you see in the right-hand chart there, the very composition of the outputs, which are ethylene, propylene, monomers of different shapes and forms for the production of various polymers and chemicals in the industry. But you have as well on such a unit, which is the largest unit on this site, the production or the byproducts of hydrogen, methane, and other fuel gases, and some products that today are mostly used as fuels. Now, if you then use a fuel exempt or fuel use exempt model, you would basically deduct from this overall input. So on the right-hand side, you see, for example, 50,000 tons of pyrolysis oil substituting 50,000 tons of classical fossil naphtha. Then you would deduct from that 25% roughly from the balance that you actually have put in. If you're looking at a system like polymer only, you would deduct all the chemicals and the fuels from the balance that you're actually using to bring forward to the applications that should contain credits or balances from mass balance systems. And here we counted propylene and ethylene in that. It may be a little, or it is a little bit more, which is why you see 45% roughly here being counted under the fractions that we can't credit to the outputs. And then you have the system of proportional, where if you're making polyethylene as a product, only the ethylene would eventually be counted towards the products. What that in practice means is that as we go for polyethylene production, we're using, and you see that on the upper left corner of the slide, a percentage of, or 75 tons would be coming out of the system as polyethylene for every 100 tons of pyrolysis oil inputted into this site. That is the fuel use exempt. If you go to polymer only, it would roughly be 55% that would be used. And if you're looking at the proportional allocation, then you would use 30%. That effectively means that from a given input that was basically built as a capacity by the chemical recycling industry, where you transform plastic waste into a feedstock for the production of polymers, and this is then transformed into the respective amounts of the output that can be brought to the market. And that is essentially the mass balance accounting rules that are being discussed on European level. How much of the input is being counted towards the output of the polymers that, in this case specifically, Dow is selling to the market, like polyethylene, but for other companies, a similar logic applies when we go through the chemical industry structure. So the objective is really substitute materials or fossil naphtha from our inputs and really bring the sustainable credits, circular credits from that to the products, like regulated in future by the PPWR or the Single-Use Plastic Directive, where we see the recycled content being needed. An alternative view, just to illustrate it, can be seen here on this slide, where you see the different allocation systems coming from a potential 10% input of sustainable input into our units. Similar on this previous slide, if you look at it like that. This percentage, obviously, as Carolina highlighted, we want to gradually increase over the coming years to the level that is ultimately the right balance for the planet and the climate on that we live, so that we can work on plastic packaging or plastic waste as the issue and bring that back into the applications that demand high quality products for the application like food packaging, which is a regulated market. You see on the right-hand side the system that we are not really discussing in Europe, which is free allocation, where you can basically attribute all the credits to the desired output of polyethylene, for example. You have the fuel use, where you essentially excludes the fuel part of the inevitably byproducts of the units that are operated today on the ground when we make the polymers that we used to in our daily life. And then you have the polymers only system, which specifically counts as credits and allows the reattribution of credits within the polymer output, so propylene turning into polypropylene eventually, or ethylene into polyethylene. So that gives you a lower amount of credits overall that you can take into the systems where the PPWR and the SUP demand recycled content in packaging, or later on in automotive as well. So these fractions go smaller. And what that eventually means, if we even go to proportional, the credited output becomes much smaller, which inevitably means, because the pyrolysis oil is a more expensive material than naphtha today traded on the markets. This means that as you need to bring to specific markets a smaller fraction of what you have actually bought and used as an input into your processes, these technologies will become more expensive the lower the amount of credits are that you can actually utilize from the system. And with that, I'll quickly cover another slide that tries to illustrate the same concepts from a different perspective, where we have here the roughly 9.6 million tons of polyolefins, so that is polypropylene and polyethylene, used in contact-sensitive applications across Europe. This can be rigid bottles, polypropylene, HDPE. This can be also other flexible packaging applications that use polyethylene and polypropylene. And so this is the market number of where we stand today in Europe. If you take the PPWR's percent target or the 7.5% target, we are roughly landing at 1 million tons of circular materials that the market eventually needs to fulfill the PPWR obligations. And then we are looking at the different allocation systems requiring a different kind of amount of input in order to satisfy the market demand for circular products at a 10% target rate of the PPWR, which you see gradually increasing here with the amount of, or with the model that is used in terms of the allocation of the input materials to the output materials, in this case, the polyethylene, polypropylene materials used in these markets. And what this indicates is that as we go from, let's say, a free allocation or a fuel use exempt system to a more restrictive system, or a system that doesn't allow as many credits to be transferred to the desired markets, you end up with a larger pyrolysis capacities that would need to be built, or more plastic waste that would be specifically needed to be transferred for a given end target. And that is the challenge that I think we are facing, that this would make the capex that needs to be built, dedicated to build more of these units, more expensive. It would also, per unit of product, make the overall system or the polymers more expensive. And whether that is accelerating a transformation is a question that we're asking ourselves. And we are very much interested to bring these products to the market in a reliable, transparent way, with the right labeling for the consumers that says that mass balance is used to bring the specific recycled content into the sensitive applications to really build out a system that is far more circular than the systems that we have today.